Okay, so let's see what these basic and basic feasible solutions look like on a graph. We have this graph, and let's say that we set the x1 and x2 to 0. Well, we're going to get a solution which is 0, 0, and x3 will be 16, and x4 will be 7. That's that point right here. The point right here is when we set x3 and x4 to 0 and we solve for the other two. So let's not write down there'll be some value for x1, x2, x3 will be 0, and x4 will be 0. If we take this point here, we have x2 will be 0. We'll have an entry for x1. We will have 0 for x2. Now x3 this is the line this will be x3 is the slack of this equation, x1 plus 3x2 plus x3 is equal to 16, and we're well within this constraint, so it'll be some number. And then there will be another number, which is we're right on x4. Well, we are right on the line, so this must also be 0. So there will be some number here. We would get that by plugging in 0, 0 as x3 and x4 and solving for the other two. Let's see what this point looks like here. x1 will be x1 will be 16. Matter of fact, I think we can say right away what this number is. This will be 7. This number will be 16, 0. Now, this time, x3 is going to be 0 because we're right on the line. And x4 will be negative because we're outside of this line. We're outside of the x1 plus x2 less than or equal to 7 constraint. If we go to this point here, we will have x1 will be 0, x2 is equal to 7, x3 will be negative, and because we're outside of this line, and x4 will be 0 because we're right on that constraint. That's this point here. This point here, we have x1 is 0, x2 is we will have x3 0. So if x1 is 0, x2 must be 16/3, x3 will be 0, and x4 will be positive, will be a positive number. As a matter of fact, I should say that x3 will be a positive number, and here will be a negative number, and these two are positive numbers, and there's a negative number, and there's a positive number. I don't have to actually be able to identify all the positive and negative numbers. All we're doing here is just keeping track of what the nature of the point is. Well, if I label these points as A, B, C, D, E, and F, the question is which ones are basic and which ones are basic feasible. So the basic solutions, all the solutions, because all the solutions A to F, all have 2 zeros. And they're all the intersections of all the lines. When I talk about lines, also the lines x1 is greater than 0, x2 is greater than 0 is also a line. So basic solutions are A to F. But basic feasible solutions are only the ones that are basic and have positive solutions. All of them are positive. So those are A is not, B, C, D, and F. Observation at this point is that the corner points are and is implied by BFS. So if a point is a BFS, a basic feasible solution, it's a corner point of a feasible region, and any point that is a corner point of the feasible region is a basic feasible solution. And we haven't proven that, but we've shown it here. So we have these same points being the basic feasible solutions are the same as we drew as corner points